So good day, I'm Enandro David Jr. and today I will be discussing histopathologic technique fixation to mounting. So without further ado, let's start. So fixation. Fixation is a chemical process by which biological tissues are preserved from decay. So as soon as possible after arriving in the laboratory, tissues must be handled carefully and fixed as necessary. A liquid fixing agent, fixative, such as formaldehyde solution, is used to fix the specimen formalin. This will gradually pierce the tissue, generating chemical and physical changes that will harden the tissue, preserve it, and shield it from further processing. Fixation is a critical step in the preparation of histological sections and should be carried out under optimal conditions. Formalin, usually a phosphate buffered solution, is the most popular fixative. Following fixation, appropriately trimmed specimens are placed in labeled and cassettes, small perforated baskets. So this is the tissue processing. So next, we have dehydration. Dehydration is the removal of water from aqueous fixed tissue. Because melted paraffin wax is hydrophobic, not miscible with water, most of the water in a specimen must be removed before it can be infiltrated with wax. This process is commonly carried out by immersing specimens in a series of ethanol, alcohol, solutions with increasing concentration to avoid excessive distortion of tissue until a water-free tissue in alcohol is reached. So water-soluble proteins are removed at lower concentrations of ethanol. When ethanol concentration is increased to 100%, certain lipids may be dissolved. So another thing, dehydration, fatty issues such as breast or lipoma may be inadequately processed in what is normally a successful schedule for other tissues. So ethanol is a poor fat solvent. So to ensure complete dehydration, a superior fat solvent such as acetone or isopropanol should be added before the final absolute ethanol. So in chloroform or trichloroethane used as the transition solvent. So a typical dehydration sequence for specimens not more than 4 mm thick would be 70% ethanol 15%, 90% ethanol 15%, 100% ethanol 15%, 100% ethanol 15%, 100% ethanol 30 minutes, and 100% ethanol 45 minutes. So this is the process of dehydration. So next we have clearing. Clearing remove dehydrating agents from tissues and to prepare the tissues for impregnation with the embedding agent. So the dehydrated tissue is transferred to an intermediate solvent that is fully miscible with both ethanol and paraffin wax. So the term clearing has been chosen because many, but not all, clearing agents impart an optical clarity or transparency to the tissue due to their relatively high refractive index. So clearing, another important role of the clearing agent is to remove a substantial amount of fat from the tissue which otherwise presents a barrier to wax infiltration. Following the dehydration, the tissue is immersed in 1 to 3 silane immersions. In these stages, the ethanol is gradually replaced with silane, and when the tissue is embedded, the silane will then be replaced by molten paraffin wax. So a typical curing sequence for specimens not more than 4 mm thick would be silane 20 minutes, silane 20 minutes, and silane 45 minutes. So next, infiltration. So remove the clearing agent from the tissue and to completely permeate the tissue with paraffin wax. So the cleared tissue is infiltrated with a suitable histological wax, usually paraffin, which is liquid at 60 degrees Celsius and then allowed to cool to 20 degrees Celsius in order to solidify into a consistency that allows sections to be cut. So to completely displace the clearing agent, a typical paraffin infiltration would sequence of paraffin for specimens not more than 4 mm thick would be paraffin wax 30 minutes, paraffin wax 30 minutes, and paraffin wax 45 minutes. So this is the infiltration. So these waxes are mixtures of purified paraffin wax and various additives that mainly include resins such as styrene or polyethylene that allow them to be sectioned thin enough on a microtome, forming ribbons that can flatten fully when floated on a warm water bath. So next, embedding. Placing cells or tissue in a supporting medium so that thin sections can be cut using a microtome. So once the tissue has been processed, it is ready to be oriented into a paraffin black and subsequently sectioned. After infiltration with wax, the tissue is oriented and placed in a mold that is filled with molten wax to form a solid tissue block that can later be clamped in a microtome for sectioning. So the infiltrated tissue is removed from the cassette and very carefully oriented in a suitably sized metal mold so that the plane of section can be determined. So correct orientation of tissue in a mold is the most important step in embedding. Incorrect placement of tissues may result in diagnostically important tissue elements being missed or damaged during microtomy. So embedding, usually tissues are embedded with the surface to be cut facing down in the mold. So after orienting the section, the mold is filled with molten wax. The main part of the labeled cassette is placed on the top of the mold and topped with more wax. So the whole mold is placed on a cold plate to solidify. When this is complete, the block with its attached cassette can remove from the mold and is ready to be sectioned on a microtome. So double embedding is a process by which tissues are first embedded or fully infiltrated with a supporting medium such as agar or nitrocellulose, then infiltrated a second time with wax in which they are also embedded. Double embedding in agar paraffin is a reliable and convenient method of handling minute and friable tissue fragments such as keratin and endoscopic biopsies which can be lost during the tissue processing. So this is the embedding process. So next, we have section cutting. Process of cutting tissue into thin slices. So once the tissues have been embedded, they must be cut into sections that are thin enough to be placed on a slide. This is done with a microtome. Good microtomy techniques will minimize artifacts that can lead to difficult diagnostic interpretation of special stains. One of the most directly correlated factors is the thickness in which a specimen is cut. Specimens for routine hematoxylin and eosin H&E are cut 3 to 5 micrometer in thickness. Tissues to be examined for amyloid deposits are better sectioned at 8 to 12 micrometer, whereas kidney biopsies should be cut at 2 micrometer for optimal viewing of the structures of glomeruli. So paraffin wax does not provide a sufficiently hard matrix for cutting very thin sections for electron microscopy. Epoxy resins are the most commonly employed embedding media for semi-thin and ultra-thin sections, but acrylic resins are also used, particularly where immunohistochemistry is required. So let's go back. So the microtome is nothing more than a knife with a mechanism for advancing a paraffin block across the knife. Knives are either of the standard thick metal or thin disposable variety like a disposable razor blade. Usually, this distance can be set at 6 to 8 microns. After sections are cut, they are placed on a warm water bath that helps remove wrinkles. Then they picked up on a glass microscopic slide. The tissue slide is drained and may be gently heated to evaporate the layer of the water between the sections. So it may also be heated enough to melt the wax, a procedure that may improve adhesion. So this is the section cutting. The specimen holder, specimen block, and the knife, microscope slide sections, block specimen knife, the cut section, and the copper mesh grid. So last, we have the mounting of tissue sections. So the mounting of tissue section is the last step in the series of histological preparation of a slide. So paraffinized ribbons of serial tissue sections can be removed from the microtome knife as they are cut by using a wooden tongue depressor blade. In this process, a slight traction is exerted on the end of the ribbon, stretching it gradually over the wooden blade while floating in a warm water bath. The temperature of the warm bath should be kept at 5 to 10 degrees Celsius below the melting point of the embedding wax. If it is too hot, desiccated looking sections will result, while cool water baths will produce excessive wrinkling of the tissue. So adding a few drops of ethyl alcohol to the water may facilitate the mounting of tissue sections. So a potentially dangerous mistake that can take place when mounting sections from flotation baths is the shedding of a small tissue fragments that float freely on the surface of the water. These tiny pieces of unrelated tissue can cause problems in interpretation of the biopsies by the pathologists. The pathologists and histologists must routinely skim or otherwise the surface of the water bath between cases. Meticulous cleaning of the microtome water bath and frequent clearing or changing of the water will alleviate the danger of rare contaminants from one case to subsequent ones. So mounting, because tissue sections do not adhere well to untreated glass slides, a bonding agent also must be a component of the water bath. Albumin and polylysine are all suitable additives of this type. So for example, a small piece of unrelated cancerous tissue may inadvertently float and be deposited on the slice of a subsequent case that is being evaluated for the presence of malignancy. So this is the mounting process. So that would be all, and thank you for listening.